Hello everyone, and topic of this video is Coulomb's law. Okay, so you have learned that two stationary charge either attract or repel each other. Okay, same charge repel each other and unlike charge attract each other. Okay, the force of attraction or repulsion between them depends on their nature. Okay, so Coulomb's studied nature of this force. So in 1785, okay, so in 1785 Coulomb's done an experiment and he saw that the electrical force between two static point charges, like two charges, suppose there is two charges, q1 is a charges and q2 is a charge. Okay, so the force between them, which is placed apart distance, let this is a distance. Okay, so he saw that the electrical force between two static charges, that q1 and q2, placed some distance apart, is directly proportional to their product. Okay, and it's inversely proportional to square of the distance, which is r or d, between them, and directed along the lines joining the two charges particles. Okay, and repulsive for some kind of the charges and attractive for opposite charges. So Coulomb's studied that these 4 points which Coulomb's saw. Okay, according to Coulomb, the magnitude of the force in mathematical we express that F is equal to K Q1 cross Q2 upon R square. Q1 and Q2 means its multiplication. Okay, simple multiplication. And for free space, F is equal to 1 upon 4 pi epsilon naught cross Q1 into Q2 upon R square. So in free space there is the value of K, which is 1 upon 4 pi epsilon naught, and the value of the K, which is a constant, is given. So what is that? That is 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9. Okay, and this is Newton meter square per Coulomb square. And the value of the epsilon naught, is 8.85 into 10 to the power minus 12 Coulomb square Newton per meter per square. Okay, so this is the value of the epsilon naught, and epsilon naught is nothing, just it is a permittivity. Okay, so permittivity of the free space. Now some important points which is note in Coulomb's law, that what the points are, that Coulomb's law is also an inversely square law. Okay, so Coulomb's law is also an inversely square law, just like a Newton law of the gravitations. Okay, and Coulomb's law holds good for point charge only. Okay, so this is only hold good for point charge only. And Coulomb's force act at a distance, unlike mechanical force. Okay, I also explained the Coulomb's law in vector form. So you know that the force is a vector quantity. Okay, and it means the force between two charges should also represent as a vector. So let there be a two charges. Okay, let there be a two charges. Okay, Q1 and Q2 are two charges. So here I saw in two figure that this is the charge Q1 and Q1, this is a charge Q2, which is that this is a charge Q1, this is charge Q2. Okay, and this is also a charge Q1 and this is a charge Q2. Okay, and force F12 denotes the force experience on Q1, the force experience on Q1 due to Q2, and the F21 is force denotes that the force on Q2 due to the charge Q1. Okay, and here also the force F12 denotes that the force on Q1 due to the charge Q2, and F21 is represent that the force on Q2 due to the charge Q1. Okay, so the force, there are two types of the force. Okay, so this direction is opposite and this direction is same. So here the force unit vector point from Q1 and Q2, so he denotes that in mathematical form. So what is that? That is F12 is equal to plus K Q1 Q2 upon mod R12 square R cap 12. So this is the for figure 1. Okay, so this is for a figure. Okay, and the force F21 is equal to minus, here the minus sign, okay, minus K Q1 Q2 upon mod 12 square R cap 12. Okay, so this is the force for Q2, sorry, this is the force for figure B. Okay, and so we saw that the positive sign in equation is represent that the force is repulsive. Okay, so positive sign represent that the force is repulsive between both the charges, and the negative sign represent that the force is attractive between the charges. Okay, so here the sign is also represents, and in this way the Coulomb's law obey the principle of action and reaction between two charges, which is Q1 and Q2, and we can represent it as F12 is equal to minus F21. Okay, and in the mathematical form in general we can write the expression for the force between two charges is F12 is equal to K into Q1 cross Q2 upon R square R cap 12. Okay, so this expression represents that the force between two charges. Thank you.